Okay, applications of quadratics, finding the vertex. So, quadratic of, hey, we haven't seen this form for a while. This is new. Well, it's not new, but hey, it's been a little bit. What form of the quadratic's that? Studio audience? Yes. Vertex. Yay, vertex form, and the crowd goes wild. Graph. Oh, graphing, yay. We haven't graphed for like 5 hours, maybe 7. Okay, let's graph. Transformations. What do we have going on here? We have, in order, we have a vertical stretch by a multiple of 2. We have a vertical. Well, say I've never called it that before. It's a vertical, this will be neat, a vertical reflection in the x-axis. Now, I've never called it that before, but it's a vertical reflection because it goes like this. It's reflecting vertically as opposed to reflecting this way. Okay? But it's a vertical reflection. But you can just, and in this course, we can just call it a reflection in the x-axis. Good enough. Then, what else is going on? Oh, I got a shift. I got a horizontal shift to the right. 3 units. And I have a vertical shift up 8 units. That's so cool. And remember, these guys have to come before these guys. Within them, doesn't matter which one comes first, but stretches and reflections before stretches, or before shifts, sorry. Stretches and reflections before shifts. Step pattern. There's a vertical stretch. It's stretching it, so we're going to go over x squared, but over x squared, I'm losing it. Over x, and then we're going to go down 2x squared. State the vertex. Well, that's what vertex form is so good for, isn't it? You can look at it and you can say the vertex is 3, 8. That is so cool. I guess we should graph it. So let's put in the vertex. 1, 2, 3, up to 8. 3, 8. And then we're going to use my step pattern to get the next one. So it's over 1, down 2 from the vertex, over 1, down 2 from the vertex, over 2, down 8 from the vertex. Well, if this is 8, then this is down 8. And then it's going to be over 3, down 18. Well, that's kind of a pretty little graph on that grid. And it goes something like this. Now, if you're taking 3.5 hours to graph this, that's a bad idea. So we got to be able to do this fairly quickly. Okay, so cool. Expand. Expand it into standard form. So this is vertex form, which is this. And they're asking us to change that into this. And that's kind of cool. We need to do some algebra here. So we're going to start with, and we're going to think. We're not going to take that -2 inside the brackets. That would be wrong. Let's think for a minute. What if I had a question that looked like this? 2 times 3 squared. Well, if you took that 2 inside to the 3 and got 6 squared, that would be 6 times 6 is 36. But if you do it correctly and do the exponents first, you get 2 times 9, which is 18. And there's a big difference between those two. Okay? So, -2, x minus 3, x minus 3 plus 8. Now, how I put these together is up to you. I either put these two together first and then take the -2 in, or I take the negative 2 into one of them and then expand the binomials. Once again, let's make myself clear. If I had 2 times 3 times 5, that answer is either 2 times 3, which is 6, times 5, which is 30, or that answer is 2 times 3 times 5, which is 15, which is 30. But it certainly isn't 2 times 3, which is 6, 2 times 3, which is 10. It's certainly not this. That's too many 2's being multiplied in there. That 2 can only go to one of the terms. So you have to make up your mind. And this is what I'm going to do. X squared minus 3x plus 9 plus 8. I'm going to bring these two together first. Negative 2 is x squared minus 6x plus 9 plus 8. I'm going to take the negative 2 into all three of these, but it does not go to the 8. That's not inside the brackets. So it's negative 2x squared. Negative times negative is a positive. So it's going to be positive 12x, negative 18 plus 8. Last thing I do is I take the negative 18 and I take the 8, and I get negative 2x squared plus 12x minus 10. And ladies and gentlemen, that is my final answer. That is pretty cool. So we've just gone from Vertex to standard. Guess what they want me to do now? Guess what they want me to do now? I have to go from factored. Well, not to, from factored. I have to go to factored. And they want me to go to factored from my answer to C. So they want me to take this and factor it. So this value comes up here, and they want me to take this y equals ax squared plus bx plus c, and they want me to change it into, do I have another color? Do I have another color? I do have another color. I'm going to change it. That doesn't look like another color. I'm going to change it into y equals x minus r and x minus s. Now, there's been some discussion at school about my s's and my 5's. This is an s. This is a 5. Yes, it's not fair. I am very unapologetic about it. That's an s. That's a 5. Moving forward. So, the form that we have is y equals negative 2x squared plus 12x minus 10. Woohoo! We're now going to factor that. But, it's got a 2 in front of it. Worse than that, it's got a negative 2 in front of it. The inhumanity of it. We're going to common factor out that negative 2. We're common factoring it out. So I put it on the outside, I put brackets. Negative 2x squared divided by negative 2 is just x squared. Positive 12x divided by negative 2 is negative 6x. That changed because negative 2 times negative 6 gives me positive 12. Negative 10 divided by negative 2 is positive 5. Woohoo! So we're well on our way. We have factored, but the question is, have we fully factored? And you will always fully factor for me. You'll keep factoring till you can't factor anymore. So we're going to take a look. Two numbers that multiplied by 5 but add to give me negative 6. I'm thinking of 1 and 5, and I'm thinking negative 1 and negative 5. What do you think? Negative 1 times negative 5 is 5. Halfway there. Negative 1 plus negative 5 is negative 6. All the way there. Which means that we have this trinomial is x minus 1, x minus 5. Do not, did I say it? Do not forget the negative 2. Yay! Ladies and gentlemen, final answer, factored form. Can I just take a second here and point out something that's very, very cool? We have one quadratic, this one, and that one parabola, that picture, can be represented as this. It can be represented as this. And it can be represented by this. That one parabola is represented by all three. That's the point of what I've been teaching you. You have to be able to go in between and know what's important about each one. You need to know their names. Vertex form, standard form, factored form. And I think they kind of make sense if you look at them, what their names are, right? I really do think it comes pretty straightforward. So they want me to state the X-intercepts. So which of these three forms is the best to get your X-intercepts from? Well, an X-intercept means y equals 0. If I put y equals 0 here, I'm in for a world of hurt. I got a lot of work to do. If I put in y equals 0 here, I got a lot of work to do. This one I need to change it into this, and then I need to change it into this. Or, if I just look here, I know that my X-intercepts are x equals 1 and 5. Done. How can you find the vertex using the X-intercepts? Now that's another question. Hold on, let me get to that. Let me finish this first. For an X-intercept, you're going to set y equals 0 and use or change the form into factored form first. So if you have the factored form, you're going to use it. But if you don't have the factored form, you're going to change into the factored form. And your X-intercepts are x equals 1 and 5. How can we use our X-intercepts to get the vertex? You had a question like this on your test. Similar, you had a question like this in your homework earlier. Let's take a look at a way of doing it. So if I have the X-intercepts, what that means is I know that it's going to cross the axis at 1, 0 and at 5, 0. That's what I know. Let me get something out of the way for the kids at school that's in the way. Okay. So that's what I know if I know my X-intercepts. The axis of symmetry has to lie halfway between there. That's your axis of symmetry. And we should remember that from grade 10. So what is the point, what is the x value right in between 1 and 5? Well, if I start at 1, I start at 5. And if I go over to 2, I go over to 4. I go over to 3, I go over to 3. So it's x equals 3. This equation is given by x equals 3. Is there another way to come up with that 3 without counting over? Yeah, you take the 5, you take the 1, you add them together and divide by 2. So some of you have learned the process of taking this value, the 1, and you add the 5, and you divide by 2, and you get your 3 value. That's fine too. Now what does that mean? That means my vertex has to lie somewhere on here. Okay? Now, if we're lucky enough to know that the vertex opens down, then we know that it's going to be up here and open this way. If we're, not the vertex, the parabola. If we're lucky enough to know that the vertex opens up, then we can put it here. But in either case, we know that for the vertex, wherever it might be, whether it's up here or down here, we know that it's 3, a number. I don't know what that number is yet, but I know it's 3, a number. Okay? All right. So what we can do now is that if I know this, if I know what the X-intercepts are, and if this is my equation, we know that the vertex must lie on the axis of symmetry. So we know that the axis of symmetry is at x equals 3, and we talked about how we got that. But what that means is if we sub in x equals 3 and solve for y, you're going to get the y value of the vertex. So what that means is y equals -2, put in 3 for x, put in 3 for x, -2 times 2 times 2, that's a -2. -2 times 2 is 4, times -2 is 8. That means that this value here for this equation is 3, 8. And is that right for our equation? So we can see it here. Oh, got something in the way that the kids at school can't see through. So it's here, and we determined it here. Okay, I'm going to stop the video here, and we'll see where we go from there.